All right, so welcome, Math 13 students. We're going to go ahead tonight and discuss section 3.2 in your text. And the title is, let me start that again. Typo. There we go. Section 3.2, measures of variation. So, a measure of variation gives a value to the spread of the data. And as I often say, data sets are very much like people. They have personalities. They're kind of complicated. They're not simple. So what that means is there's always more than one way to look at a data set. And you need to look at a data set any number of different ways to really try to get an understanding of what it's trying to tell us. So let me give you an example. I have two classes. I have class A and class B, and I have some exam scores. The first class, it's a small class, there's only 3 people in the class, has the following exam scores: 74, 76, 78. Class B has 56, 76, and 96. Three students in that sample also. So the first thing I'm going to note is that if we plug this into our formulas for the mean, I find that I have a mean of 76 in both cases. And quite clearly, looking at the actual exam scores, it's really clear that there's a difference here. The 74, 76, and 78 are very close together, while the 56, the 76, and the 96 are really pretty far apart and spread out. And so that's what we're trying to get a handle on. There's a way to measure that kind of detail, a measure of variation. And like a measure of center, we're going to have several measures of variation. We'll have a total of 3. And I'll start with the most basic first. And the most basic measure of variation is what we call the range. And the range is just the difference between maximum and minimum values. For class A, in that previous example, the high was 78, the low was 74. We had a range of 4. So I'll use the letter R for range, so R equals 4. For class B, we had 96 minus 56, or 40. So the range there was 40. We have no special notation. Either I write out the word range or I'll use the letter R. It'll be obvious what's being said. But the important thing here again is to note the fact that the range is, at the end of the day, a simple difference between maximum and minimum values. Your calculator will not give you the range directly, but it's very good about providing maximum and minimum values. And we'll run through a more complete example in just a bit. All right, so next up is what we call the standard deviation. Now, the standard deviation is used a lot. It's a very important number. And you can think of it this way. The standard deviation is kind of like the average distance between a value and the mean. Excuse me, oh, sorry, a value and the mean. There is some subtlety. I'm going to run through some basic examples first, and then we're going to actually come back and take a little closer look at what this definition implies. We do have a couple of formulas that go along with this. If I have a sample, I have notation. Lowercase s for standard deviation. I add the difference between the x and the mean squared. I divide it by the sample size minus 1, and then I take a square root. It's a little confusing right now, but you'll see why we do it this way in a moment. By the way, your calculator knows this formula very, very well, and it will provide you with the result without any problem whatsoever. The population. The standard deviation for a population gets different notation, just like the mean does. This is this is the Greek letter sigma. It is lowercase, and it's how we designate the standard deviation of a population. Since we're working with a population, I'll use mu for the mean. The formula is almost the same, but it's got a slight difference. And again, I'll talk about this as we proceed with the discussion. So we have the range and we have the standard deviation. And again, your calculator gives you this directly without any problem whatsoever. You just have to know how to interpret what your calculator is saying. And it's not hard. And then there's a final measure of variation called the variance. And the variance is the square of the standard deviation. And again, we have two formulas and notation. The notation is s squared for the sample variance. And it is just what we saw on the previous formula without the roots. And again, you have no idea why this construction is the way it is right now. I will run through an example in just a bit that will clear up, hopefully, a little bit of why the formulas look the way they do. All right. So I've got my three measures of variation: the range, the standard deviation, and the variance. Now, as I said, your calculator works very much with the standard deviation. It can give you the variance, and I'm going to show you how to get it. It takes just a couple of keystrokes. It's not given to you directly, but it's something that we will need. So I will be giving you those keystrokes too. Now, before I run through my example, let me state the rounding rules. And as I've said, students seem to think that there's a bunch of rounding rules because I'm always writing rounding rules, but they're really pretty much only a handful of them. The rounding rules here are no different than the ones we saw in section 3.1. So for the range, standard deviation, and variance, we carry one more decimal than the data. This is the same for the mean, the median, and the mid-range. So the rounding rule is exactly the same. So it's not really a different rounding rule really at all. It is just an extension. So you want to keep that in mind as we go through the examples. All right, and then after we've done that, after I've gone through my example with my calculator, I'm going to come back and we're going to talk a little bit about the formulas. I'm going to run through a demonstration as to why the formulas are the way they are. And then we'll take a look at the uses of the variation and that the various types of variation. And depending on the time, we'll talk about important distributions. That may have to wait until next time, but we'll see. So here's my example. I'm going to find the range, the standard deviation, and the variance for, well, let's see, commute times. In minutes, and we have a sample. And that is going to be an important consideration. So here's my sample. We have commute times in minutes. We have, let's see, 49 minutes, 61 minutes, 30 minutes, 24 minutes, 63 minutes, 18 minutes. Oh, just a few more because it's fun. 22 minutes, 23 minutes, 41 minutes, 50 minutes, 55 minutes, and we'll leave it at that. So I believe that's, let's see, 6, 7, 8, 9, 10, 11. All right, so there's my sample. Now we're going to go ahead and find the range, the standard deviation, and the variance. I'm going to find the standard deviation first, then the range, and then finally the variance. We're going to do it sort of in a bit of reverse order because it seems to work better with that order on your calculator. So let me go ahead, share my screen, bring up our calculator, get rid of all that. All right, so if you've got your calculator with you, you can certainly bring that out and take a look at what we're doing here. I need to get that data into my calculator. I've got a list in there. I'm going to clear that list by highlighting L1 and hitting enter. And once again, there's many videos on the Canvas site regarding using your calculator. Look in the lecture notes and you'll see them. So in we go. We got 49, 61, and 30. We have 24, 63, and 18. We have 22, 23, and 41. We have 50 and 55. So my data is there in list one. I will hit stat and select calculate my one variable stats. So it's the exact same place exact same place that we went to before. I'm going to stop my sharing for just one moment. I'll be right back. Yeah, okay. There we go. I thought I lost someone. I think they're coming back. There they are. Hey, welcome back. All right, so good. So I select the one variable stats. I have my data in list one. That's the only place I have my data. I'm going to leave the frequency list blank, and I'm going to hit calculate. Now there's the mean, which we talked about the last time we were together here. And then we've got all the other stuff that we talked about the last time also. I'll need the min and the max in a moment, but right now I'm focusing on the standard deviation. Now, it's very important that we read our questions carefully because there is a difference in the formula. For the, I think maybe Edgar's got his microphone on. Edgar, yeah, Edgar. There we go. Hey, right on. Thank you. So it's important to realize that I have here the sample standard deviation and the population standard deviation. I'm going to try this. I don't use it much because it tends to annoy me. So I'm going to try spotlighting the sample standard deviation and the population standard deviation. Yeah, see, it looks awful sloppy, but there we go. So I need to know which one of those little guys to pick because they are different. I'm going to be rounding to 1 decimal place. So there would be a difference in the outcome. You might get your question wrong, your answer wrong if you choose incorrectly. We have a sample, so I will choose my first number here. Let me clear that away, clear all the drawings, and get rid of that entirely. So 16.8. So let me stop my sharing now and write for my standard deviation S equals 16.8 minutes. So that's my sample standard deviation. Now, I'm going to write my variance. Next. That is S squared. Now, we have a bit of an issue here. I do not want to take my 16.8 and square that. The reason is the 16.8 has been rounded rather significantly. There are a lot of decimals there, and I really need to round all the decimals with all the decimals in play. And then there's one other thing to get to, but I'm going to wait for just a moment there. So let me come back to my calculator. What do we press for the list to pop up? You mean L1? Let me go through those keystrokes again. I've got to go back to that screen anyway. So to get that to happen, I need to select calculate. And then if that is empty there, you'll notice on your keys down here, the 1, 2, 3, 4, 5, 6 in blue have an L1, 2, 3, 4, 5, 6. My data was living in list 1, so I go second. I get the little up arrow there. And when I select the 1 key, I get the L1. The frequency is left blank because I only have a single list. Then I can calculate the result there. Okay, so hopefully that works that way. It seems like that might be what you needed. So I see the 16.8182801. Now, I really don't expect people to write all those decimals down, then type them all into the calculator. look, there's a place for human error, but this isn't it. My calculator is well capable of giving me the variance. So here's how I go about doing it. And I'll go through the keystrokes a couple of times. I see the vars key down here. My calculator remembers everything that it does with a data set until we give it another data set to work on. Then it remembers that. So when I hit vars, I will note that option 5 is statistics. And that's us. And I've got a lot of drop-down menus, but the only one I'm interested in today is the very first one. Number 3, SX, is my sample standard deviation. The notation is a little odd with the capital S and the little x, but there we go. You'll note that the calculator actually does a reasonable job with the Greek letter sigma. So that's my standard deviation, the x and the x. It doesn't look impressive, but if I hit enter, I see all those decimals. So as I say, vars, statistics, pick up the sample, standard deviation, and then I'm going to use the x squared key. So it's going to take that 16.8 and change and square that out. So I get 282.854 and change. For comparison, 16.8 squared is 282.2 and change. The values are different. Oh, not by a lot, I'll grant you that, but by enough that if I put both on a quiz as the result of a multiple choice question, only one of them is going to be right. So be aware of that. We want to use the on-rounded version. So 282.9. Let me go ahead and stop my sharing. So 282.9 minutes squared. It's important to remember, and I see the question there, I'll get to it in just a minute. It's important to remember that when we're talking about the variance has a square in the notation, and the units are also squared in the process. So, as I say, there's a little bit going on with the variance. Now let me finish this up with the range, and then I'll come back and address the question I see in chat. So my range is equal to, and as I say, my calculator does a very good job, of giving me, so I said stat, calculate, one variable stats. Oh, I think you meant the other guy there. Okay. I'll go over those keystrokes again in a minute. So I've got the range right here. I've got a minimum of 18 and a maximum of 63. 63 minus 18 is 45.0 minutes, and I'll give it the same rounding. Okay, I did see that question about where I got the variance. So I saw, who was it? That was very helpful that I saw that in the chat, that little shout out giving directions. So let me just point out and reiterate what I saw in chat there. Once I have calculated my standard deviation, vars down to statistics, and after statistics, this is where I need to know what my calculator is trying to tell me, because this is what you'll see on your output screen right after the one variable stats. So that's what I want there. And SX pops up and I square it out. And there we go. Now, I'm going to stop my sharing for just a few moments. We'll come back here in just a bit. Let's see, what do we got going on down? Can you go over the chapter 2 review? Yes, I can go over the chapter 2 review. So let me go ahead and put this on hold and go over the chapter 2 review. Now, do you have a specific question off the chapter 2 review? It helps if you have a specific question out of the chapter 2 review. If not, I'll just bring up the screen. Let's see, where are you? Is this it? I think this is it. Yeah, there we go. So you're talking about the chapter 2 review, spring 22, this guy right here. Yeah? Okay, I see the yes. Are you going to post this Zoom on Canvas? If I don't post this one, I will note that there's already a couple on there that deal with the same topics under the office hour videos. But if you'd like, sure, we can post it, I suppose. It's not that big of an issue. So there's the review. And these are the kind of questions that I would be asking on an exam or a quiz. I wouldn't ask you for all of them, but if you want, I can go over some of them. So let's see. Specific questions. Let me go over this guy right here where let's see, chat. I see 6. So question number 6. Which outcome is the most common? In the frequency distribution, the 70 to 79 outcome is the most common. If that is the correct question I am attempting to answer. 6 and 7, sure. Which outcome is the least common? Which class has the smallest frequency? The first guy here. They have the smallest frequency, the 50 to 59. That is the least common outcome. Other questions out of the chapter 2 review. Are you guys clear on relative frequencies? Let me go over that particular problem for a couple of the relative frequencies and then for the cumulative frequency down below here. So the first thing we need to do is to sum the values that we see there. So let me go ahead and get my calculator up here and note. Let's see. Hold on. Let me do things right here. Okay, so hold on. Just give me a moment. I'm trying to juggle a lot of screens here. Apparently, it's rather difficult. Okay, so let me get my data set going. Be patient. I'm almost done. And we got income and we've got frequency. We've got, let's see, 13, 19, 13, 23, and 2. All right. So let me go ahead and share my screen. Where are you guys? There you are. All right, so that's what I've got there. So you guys can see that. So that's the frequency distribution for income. I'm going to calculate the relative frequency and the cumulative frequency for this distribution for this data here. So the first thing I am going to need is I am going to need however many people people here we took a look at. If I go back to my calculator, you're not going to see me add those up, but I'll take the 13 plus 19 plus 13 plus 23 plus 2. I add those up and I'll get 70 when all is said and done. So my grand total was 70. Now, this is my frequency. The relative frequency requires I do a little bit of math. I need to take the 13 and divide it by the 70. 19 and divided by the 70. 13 divided by the 70. 23 divided by 70. And 2 divided by 70. Here again, the outcome, the math, I should say, is really, really basic. So my calculator is very good at simple division, and you guys are very good at that. Does it have to be in percent or decimal? It's usually in decimal, but sometimes it is in percent. If it is in percent, it is not incorrect at all. You'll most likely encounter it in decimal format. So let's see. $13 divided by 70 is a 0.1857186. And then by the way, there's another 13 down here. No reason to do it twice. Then I'll do 19 divided by 70. 2714, 0.271. Then I'll go 23 divided by 70. There is no hard and fast rounding rule. I'm always very transparent in what I'm looking for. A 0.3285, 0.329. I'll show you my calculator screen in just a moment. And then finally, we have 2 divided by 70. And I get a 0.0285, so 0.029. So as I say, if I run through the math, that's the way it looks. On my calculator, it was very, very basic. So let me share my calculator here. You can see how I just did the basic division there. It was really straightforward. And again, no reason to do the 13 divided by 7 twice. So that is my relative frequency distribution. If I wanted it in percent, I would just move that decimal 2 places to the right. Now, the last one up is what we call, or what is called, the cumulative frequency distribution. And that is the running total. And it starts with the total in the first class. Then I'm going to add the second frequency in there. So I start with the 13. Then I'll add 19. And I get 32. And I'll show you my screen again in just a moment. I'll add 13 and get 45. I'll add 23 and get 68. And I'll add 2 and I'll get 70. So let me show you my screen. on my calculator the way I did it. So it's kind of hard to see. But the first class had a frequency or a count of 13. The second class had 19. So the two together was 32. The first three together is 45. The first four together is 68. And the first five together, all of them together, is 70. You know you've done the right thing in some sense if that last number, let me stop my sharing here. If this guy here is the same as this guy here, they've got to be the same. Otherwise, something has gone amiss. So there's the relative frequency and cumulative frequency distributions. Those are what we need to have you build from a frequency distribution. The other thing I want people to be able to do from a distribution is to take a look at the frequency distribution and decide, is this a normal distribution? It's a judgment call, but it's not a hard one to make. I'm going to come back to the page in a moment, and I'm going to remind you what a normal distribution looks like. Normal, or sometimes it's called a bell-shaped distribution, has the following pattern. So the counts start low. There are 1 to 2 high counts, or highest counts, in the middle. Counts finish low. And they are approximately symmetric. Those four things are the requirements for a normal distribution. So let me give you an example of the sort of thing that I mean, and then you can determine if the example we just got done looking at, oh, that's too sloppy. If the example we just got done looking at will fall into that category. So I'm not going to worry about what the classes are. We're worried about the frequency because that's where the pattern is. So we've got a couple of classes there. Let's see, we got a 6, we got a 10, we've got 29, 33, 8, and 4. So if I've got a pattern that looks something like that, I will note that my count starts low and it increases to a high point here in the middle of my data, and then the counts go back down to another low point. It's not perfectly symmetric, but it's pretty gosh darn symmetric. That's really the pattern we need to have you pick up on. Now, if I come back to the chapter 2 review question, the question is this an approximately normal distribution? Do they start low, have 1 to 2 high counts in the middle, and finish low? Does this follow this pattern here? Is that the pattern for a normal distribution? And the answer is no, not really. I don't make it a hard question to answer correctly if you remember what the definition is. Remember where in your notes to go to get it. So there we go. That's my chapter 2 review. Are there any other questions on that? We can certainly go over more if there are. If not, I want to just talk just a little bit more about standard deviation. All right, so let's see, what do we got in chapter 2? So we got, I see number 4. So let's see, number 4. Class width. Oh, that's a good one. Let me bring that guy back. Where is that guy? Where'd he go? Oh, wait, I see it. Tried to hide, but here it is. Yeah, let's talk about class width. All right. Class width is a little bit tricky in some cases. So let me come back to our table here. So you're talking about the difference between the classes or how wide classes are. Now, here's the issue that we face. Well, there's a couple of issues that can be a problem. First, let me go ahead and put the definition of class width up here, because part of the issue with class width begins with the way that object, the notion, is defined. So, class width is the difference, so it's going to be a subtraction of some sort. This is the difference between and I got to be careful here because consecutive lower class limits or consecutive upper class limits. And that there is the problem, because number one, we've got 2 ways to talk about class width. They should, by the way, give you the same answers. So you shouldn't get different answers. However, having said that, there's one other issue with this. Class width is something different than what most students want it to be. It is not an upper class limit minus a lower class limit. It is not that. That would be really straightforward. We wouldn't need this sort of complicated statement. So it's not this, and that's the reason we've got this. So let me go ahead and show you the class limit issue for the example in the handout, or I should say the review. So here again, this time I don't care about the frequencies. I care about the class limits now. All right, so those are my classes. And let's talk about the width of the first class. Now, I have to use either consecutive lower class limits or consecutive upper class limits. Excuse me. And it does not matter which I use. Notice, if I use consecutive lower class limits, I've got 800 minus 400 equals 400. If I use the consecutive upper class limits, I've got 1100 minus 700 or 400. So it doesn't matter which one I use. Here's my second class. For my second class, I'm going to use consecutive lower class limits. So it's 1200 minus 800 or 400. I'm going to use all of the codes. For my third class, I'll use 1200, excuse me, that's 1600 minus 1200 or 400. Greater than or equal to 2000. Here's another way of writing that that might make it a little bit clearer. This is 2000 and up. So for this guy, come back here. There we go. 2000 minus 1600 or 400. Now, the last one gets a little dicey. Why does the last one get a little dicey? It gets a little dicey for two reasons. I can't use consecutive lower class limits because there is no another consecutive lower class limit. I also can't use consecutive upper class limits because this guy here is essentially undefinable. It goes up to any number of any amount or any value. So for this last class, there is no width at all. It's got, or essentially perhaps infinite width. Now, I'll be honest, this is a little off the beaten path, and you won't see one of those on your quizzes or your exams, but it deserves some thought. Other questions off of the Chapter 2 review. Are there any other questions? Let's see. Chat is blank. Okay. And by the way, we're just about out of time, so let me go ahead and jump back to my other camera. And we'll wrap this up. There we go. All right, let me stop my recording.